Hi and Assalamualaikum. This is our group project for the integrate design project. So for our group, we choose a smart inhaler. So we go through for a group member. So we have 5 person in our group. So for member one is Mata Raj anak lelaki Ala Bachandran. For second is me Nur Adilah binti Abdul Talib. My third member is Muhammad Syakir Irfan bin Muhammad Kishore Omar. The fourth member is Muhammad Akram bin Hamdan and the lastly is Tong Chia Ye. For this is our supervisor for the integrate design project, which is Dr. Ilyani binti Ramli from a Fakulty Kejuruteraan Elektrik and Elektronik. So this is our content that we want to explain in our slide for a smart inhaler. For first is introduction about our project, which is a smart inhaler. The second is a problem statement. Third is objective project. Four is scope of work. Five is step analysis that stand for social, technology, environment, economic, and politics. Six is NABC analysis, which is stand for need, approach, benefit, and competition. Seven is our flowchart project. Eight is result of the project. Nine is our conclusion. 10 is recommendation for the future about a smart inhaler. So let's go to the introduction of the project.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akram Hamdan and I will present introduction of the project. Asthma is a widespread chronic respiratory condition that significantly impacts patient quality of life, with poor asthma control often resulting from improper inhaler technique, inconsistent medication adherence, and lack of real-time monitoring. The second thing is asthma inhaler that integrate sensor and digital platform to track medication usage have shown promise in improving asthma management. Challenges such as usability issues, patient engagement, and integration of technology into existing care routines persist. So we have 4 points for our problem statement. The first one is traditional inhaler and medication are available. Poor asthma control is often due to issues such as improper inhaler technique, inconsistent medication adherence, and lack of real-time monitoring. The second one is, despite their potential benefits, smart inhaler face challenges in widespread adoption, including issues related to usability, patient engagement, and integration into existing asthma care routines. The third, asthma is prevalent chronic respiratory disease affecting millions globally, significantly impairing patient quality of life and imposing a heavy burden on healthcare system. The last one is there is a critical need for innovative solution that address the gaps in asthma management, focusing on user-centered design, sensor accuracy, and seamless interface for both patient and clinicians. For our smart inhaler, we have three objective project, which is number one is to design a real-time inhalation suggest device monitoring system to improve medication adherence through user-friendly features. And the last one is to evaluate the device performance.
So for scope of work, the first scope is developing a portable and easy to use inhaler with smart filter. For the second scope is an integration of sensor of monitoring, which means it's a quantity of dose taken or automatic record by a smart inhaler, and cycle inhale and puff count are tracked in a real time. So for the third is a real-time data transfer and notification, which means we use an integration of mobile apps to send a notif by use a blink and USB. So for the notification system, we counting the amount of puff and send a reminder by using a Blink apps. So for the fourth is a power efficient solution, which means we use a efficient power to manage to support a long term without frequent recharge. So for five is a testing and validation, which means we test the performance of a smart inhaler that we create. Hi, my name is Nadila binti Abdul Talib and I want to explain about step analysis. STEP stand for social, technological, environment, economic, and politics. So this slide about social and technology. So for social, the STEP analysis is for rising knowledge of asthma and chronic respiratory disease make people seek efficient in intervention more often. For the second point is patients are beginning to demand social and responsive healthcare solutions relevant for delivering instant feedback and supporting medicine use. In case of chronic illness, patient families are usually involved in caregiving hence its need for tools to help in communicating and delivering care. So for technology, the advancement of Internet of Things IoT also enable the real-time collection of data for patient which further expand overall patient management. The second is smart inhaler can incorporate machine learning algorithm to analyze the usage pattern for the device and thereafter give feedback to the user on the correct inhalation technique and correct consistent usage of the device. Okay, for the economy, smart in health are still in the infancy, therefore there are still prices to produce. Though it is believed that as technology continues to develop, the manufacturing price of smart inhaler will continuously decline to make them affordable to the patient. As a result, improved adherence could unlimitedly decrease costs of healthcare are associated by emergency treatment and admission. So for the environmental, even if new designs are being developed more frequently, the amount of waste and energy required by this new piece of equipment is also taken into account. So for smart inhaler can come with a further that track the environment quality of air around the patient so they can avoid area that will trigger the alignment. So, for the last step is a political. Healthcare legal system and industry standards are important for market access, things like data protection and privacy for patient records. For the second point is permissive government measure touching on the expansion of access to necessary healthcare service may increase the use of smart inhaler.
Hello, my name is Maharaj. I'm going to present you about the NABC. So, starting off with the NABC, first of all is need. The need is of the project will be medication non-adherence. Past studies have attributed that most patients with asthma and COPD have poor compliance with their treatment regimens, and as such they experience poor health outcomes and end up expenditures. Moreover, monitoring challenges. Inhaler usage and the proper technique, especially in children, can be a challenge to quantity. Personalized care. The need for personalized health care that would assist in managing diseases that are long standing in nature. Moving on to approach. Smart inhaler technology, smart gadgets with abilities to track usage, inform the user in application form, and remind of the activity. Data integration. The use of mobile technologies to enhance the interoperabilities of continuous shared information between patients and clinicians. User engagement. Engaging elements that will inform the user on how best to use the inhaler and the most correct way to use it. Moving on to benefits. Improved adherence. Improved compliance of patients improves their health, hence the reduction of asthmatic flare-ups. Cost effectiveness. Possible decrease of frequency in hospitalization due to improved disease control. Enhanced patient outcomes, effective self-management and better quality of life and less symptoms. And finally, competition. The competition will be with traditional inhalers because traditional inhalers does not show high monitoring capabilities present in smart inhalers. Other digital health solutions, over-the-counter health applications that are not specifically designed to support or enhance the use of an inhaler or in relation to respiratory illnesses. Market barriers. Other limitations include cost compatibility and the appropriateness of proof of clinical usefulness.
So this is flowchart of the project. So for first, we start the program. After that, we pressure the smart inhaler, and after we pressure the smart inhaler, the node MCU will count the path that we use, and after that, if we can know, if the path will send the notification in the apps or the phone that we use, and after that, the data will be collect in the cloud. So if the path will decrease, so the users can get a reminder from the notification, and after that we end the process.
So the result of the project, by completing this project is expected to achieve the result as follow. The prototype will display the total number of path used. The user will notify via email and message about the path that we use.
We can conclude for our project, the smart inhaler developed in this project successfully integrates several design features aimed at improving medication management and supporting better respiratory health. Key design features include the use of a gas flow sensor to detect the gas release during inhalation, an ESP32 microcontroller for processing data, and the mobile application for real-time feedback and notification to users. Additionally, the IoT functionality via the ESP32 module enables users to track their inhaler usage and receive alerts regarding medication status, ensuring consistent and proper use of the inhaler. We have a few recommendations for our smart inhaler project, which is the number one, GPS tracking for inhaler location. Integrating GPS functionality into the smart inhaler ensure user never misplace their device. Integration with wearable device. User can monitor both respiratory data and general health metrics such as heart rate and physical activity, fostering a more holistic approach to managing their well-being. The last one is develop one new smart med apps, allowing users to track inhaler usage, receive alerts when medication is low or expired, get reminders for doses, generate detailed usage reports, monitor environmental triggers like air quality, and stay informed about the inhaler's expiration and maintenance.
This is our smart inhaler prototype.
When I press the button on my prototype, the LCD displays the number of puffs used. Simultaneously, on the BLYNK web dashboard, you can observe the data being updated in real time as I interact with the prototype. This ensures seamless synchronization between the hardware and the online monitoring system. After that, I push the inhaler. As you can see, when the puff used is at 166 until 179, the LED color is yellow. When the puff count reach 180 puff, the LED will turn red, the RGB LED function as an indicator. Function yellow button at the top is to reset the counter back to 0 again. And then I press the inhaler, the LCD will display again 1 puff used. And the RGB LED will turn to green. It also make the counter at the BLYNK will become 0 again. In the same time, at BLYNK web I already setting the notification. As you can see, the notification will notify you when the inhaler you used reached 50 puff, 100 puff, 150 puff, 170 and 190 puff. You also can check how many puff you take in certain time at this chart.